Time for the good stuff. Time to fine tune the model. This is where you can really stand out, I think. But already we're off to a good start, and that's because of the knowledge to use the XGBoost regressor and to shuffle the data. So we're off to a good start. Okay, so I don't want to always rewrite a grid search function. So what I did is I looked up in previous code for this class. I went to File, you can see New Notebook. No, I said that incorrectly. I went to File, Open Notebook. Okay, and then I can scroll down and try to find like where's a notebook for this class in which I was fine tuning, and I wasn't sure about some of them. I have some different notebooks up here, but I was sure. Oh, here's another one, random forest tuned. I'm gonna try that one. Okay, because I believe, let's check, if we're tuning it, it likely has I'm usually using grid search functions, and you can see here I do have a grid search function. And furthermore, this one is better because it's using the negative mean squared error, which is what we are using for regression. There's the k-fold built in. So, and it's got, you can see the random RMSE scoring. This one is also rounded, so this is like a particularly nice one. Okay, so go to that, copy it, and put it in. All right, so it's defined. Let's just look at it carefully. We have to put in the parameters, okay? The random equals false is something we can choose to do. We can choose to select, if we want random true, we can use randomized search CV. And you know what? We could actually start with that. It's often a good starting place to find out what we can get. And so what we're going to need to do then is to set up a wide range of XGBoost hyperparameters. Okay. So, and recall that parameters actually come in a dictionary, right? So we're going to need to put in a dictionary. Before doing a big data, let's just do one, okay? Is the model specified? Model, do you see how it's been defined here as just model? But model is actually specified here, okay? So that's what it's going to use. Okay, so if I usually do it like this. I'll say the params first, and then so it's a dictionary, and in that dictionary, let's just start with one of my favorites, max depth. Actually, maybe in estimators. Start with in estimators. So that's the number of trees, and then default is 100. Now, let's try I don't know, I usually just go with one less, 100, 200, 400. That's just a potential starting range. And then I want to call the function, so grid search, and params. I think it's actually, it uses params by default, so I think, well, I'll just write it in. Okay, so press shift enter, let's see if it works. Yeah, random forest regressor is not defined. We don't even want the random forest regressor. We want the XGBoost. Okay, so model, this is the issue with copying and pasting code. Model was redefined here, but we actually already defined it. Okay, so we don't want that. Okay, try it again. Rerun the function. Now try the code again. And you can see we got a much better score with 400 estimators. Now, I think it's worth trying to tune estimators by itself first. So we could try a little more. And the reason why is because, I don't know, if you always tune the number of estimators when you're fine tuning, it can result in it just changes things because 1,000 estimators is going to take way longer than 50. And that presents issues. So I often like to tune an estimator separately, but do note that it can make a difference, meaning you might end up with an ideal grid search that's based on 400 estimators, but it could be better or worse if you then change it. I mean, if it's worse, who cares? But the point is, it could be better. And you could end up with different combinations, could even work better with lower in estimators. I guess that's my point. Okay, so if that's the best one, let's check closer to that range. Like we could check 250, 350, 450, 550. You know, there's no right and wrong. You just want to try to narrow it down. That's all. And what's cool is that we consistently have a score now that we're trying to beat, the 624.12. And you can see, hey, it went up, it got a little higher, but actually it got a little worse. Sorry, but even if it was like a little better by a couple decimal places, sometimes lower is better. So we'll stick with 400. Okay. See, I said I was going to use the randomized search, but I think I might just do max depth and estimators together first and then look at the rest. So I'm going to leave this set to 400. Okay. And that's how I can do that. Okay. Now I do a comma because it's a dictionary. Now let's try max depth. So that's how long is each tree. And I don't know, let's pick a range of values, right? Sometimes one is fast to test. Why not try it? 2, 4. See, I start to double them. 6, 8, 10. You can choose to be more thorough. And so each of these XGBoost, models are going to be built. So for instance, when it's 1 with 400, it's going to take, sorry, I wanted to pause in my thought once I see the score come back, which is that max depth of 2 is an improvement. And you may wonder about this, like, why is less of a depth better? So recall that the depth is how deep the tree is, how many splits are there, right? More splits going to result in more accuracy. But the gradient boosting model is based on correcting the errors. So max depth of 2 means for each of the 400 trees, it's only got 2 splits. So it's able to pick up on some of the generalities a little better. Now, the other thing is note that we don't have 2 gave the best, but we don't have 3. So we could compare just 2 and 3. I think that's worth comparing here. So it's always nice to put the same one in to ensure that you do get the same score if it doesn't improve. That's what should be happening. And also, if you understand what max depth means, how many splits, so we did get the same score. It makes sense that you couldn't put in like 2.5 because you're either splitting the data one more time or you're not. Okay, so this is a great start to the grid search. And the next piece that I want to do is look at like a big range of other hyperparameters for XGBoost. Okay, and when you're doing that, again, like I'm not necessarily doing it from scratch every time. If I've done it before, maybe I can look at some of those ranges again. And so what am I doing here? First, I'm setting the best value so far in estimators. So I've got 400 trees with a max depth of 2. And now I want to include a lot of other parameters just to see if I can find like different combinations that work better. I also want to say, we are focused on fine-tuning kind of here in this class. However, if you go back to the data, if you look up here, other things could actually help it. Because it could be the case that getting rid of extraneous columns like potentially instant will make the scores better. Okay. And so I mentioned that because it's not the only way to kind of improve your scores. You can actually do things like get rid of columns. You do a lot of interesting stuff like that. But for now, let's just do this. Okay, so what are the other ones? And again, how do I remember? I can look them up, but I can also use my code. So if I go back to File, Open Notebook, and previously in this class we did, I want to look at the last one, I think, Discovering Exoplanets and Balanced Data. I think there's one before that. Okay, let's just look at this one. And I want to see, like, what did I use before? Now this is a different data set, it's a different focus, but if I scroll down to the end of it, and I should find like some fine tuning, that's going on. And you can see I did start here, like call sample by tree, call sample by node. And here I tried all three of these in conjunction, right? So these limit the columns. And then I also tried the learning rate here. And so I'm looking for kind of a comprehensive list. Looks like I didn't go beyond that. We're going to go beyond that. But let's start with that approach. So we could try like it kind of makes sense to try the learning rate first. Okay. And so the learning rate, it's kind of like how the models are actually built. They're actually built on adjusting, like they update, right? So it randomizes and it's like, okay, you got to improve like each little iteration. We're not talking each tree here. We're talking each iteration. Like how does it choose the parameters? How does it choose the quote multipliers? Well, when you're looking for a point in the curve, it chooses by adjusting the learning rate. So this is how much the adjustments are. And these are often started off in factors of 10, and they're actually hard to beat by factors of 10, meaning like when you go in between, but you certainly can. And I forget what the default is, if it's 0.01 or what. It's usually not over 1, I can tell you. But you know, this is a big, small data set. So the way to think of learning rate is that it's how, like, you start with a random set of numbers, and now you got to change them based on the errors. Well, how much do you change them by? Low learning rate means you change them just by a little bit. High learning rate means you change them by a lot. Okay, that's the general idea. So let's see what it gives back. Oh, it ran it, but I didn't do call the function. So it ran that dictionary. Awesome. It's a cool dictionary. But the point is to put it in our grid search function and see what is it actually going to deliver here. Well, okay, so that does look like maybe the XGBoost default because it gave the same score, right? It didn't show any improvement. But now that I have that information, I can now look kind of closer by that, right? So if 0.1 is the best, 0.01 was not better, what about 0.05? What about 0.02 or 0.3? Okay, so that's a little bit of a closer range. And I could even be more specific. You know, I started counting by 0.05s, so I could include that. Okay, let's see. And again, no single right way to do this. I'm just starting by taking one hyperparameter at a time and looking to fit in the range. Yeah, it looks like the 0.1 is consistently delivering the best. I'm not necessarily going to push that further. We can just leave it. I believe that's the default. And by the way, it is conceivable that it's not, there's another one. And how do you know? Well, you can, here, if you type in model, because we set the model as the XGBoost. Oh, shoot, it doesn't give all the hyperparameters. They often do. If I just type in XGB regressor, you see it's showing the, sorry, wrong button, enter there. And I can, there, yeah, see it just shows you, and you can look. And these actually, this is a cool way to actually see all the different parameters that you can fine tune. So you can see that it does show a default learning rate of 0.1. Okay, but that's considered a little large, but it's fine for like smaller data sets. And this data set is actually kind of small. So we can't leverage the power of XGBoost as much as we could in others, you know, I would say. Okay, next, let's go to the call samples. So if I go back here, I think this is a nice little setup. We're going to change the numbers of them. And I will do a randomized search, by the way, at some point. So, oh, and this is another way to run the function even, because do you see how I'm putting params and then calling it, but you can also call it like this. Well, for us, max depth is 2 and estimators is 400. Now, I want to change these ranges a little bit. So I believe this is the number of columns, not the number of rows. So, you know, we don't have that many columns, okay? It's always important to have an association between what you put, what numbers you're putting in and your code. If you're saying, hey, I don't have a lot of columns, you know, it could be that just leaving one of them out is significant. So I'm going to count maybe by 0.2s here. And it does, this is the thing too. These are ideal for like a random sorry, a high number of columns. And with a smaller number, you could just actually try to eliminate some and use your own discretion. But here, I also want to say it's going to try every combination. So this would be 3 times 3 is 9 times 3 is 27 models. Okay, this up here is 1, 2, 3, 4, 5. Now, if we get into some timing issues, which is what we talked about, 27 models, max depth is only 2, but in estimators is 400, right? So that's a lot. We're looking at, like, if you count decision trees, 27 times 400. Python's a great calculator. 10,800 in trees. Okay, so that's a lot. I kind of want to just see. Let's see how it does. Okay, this can give us a good baseline too. You know, I could easily take one of these out, and so if like 3 times 3 is 9 times 2 would be 18. But let's just give it a whirl. Okay, so that's going to take a little time, and you really got to be cognizant of how many models that you are building, because you don't want it to take too long. Now, instead of just sitting here and waiting for it, I'm going to say, hey, it's going to deliver like some kind of result. It did it pretty quickly. And look at that. We got a better score here using the combination that you see. You know, cutting down on some of the columns is helping, which makes sense, I think. What I say makes sense because when you look at all the data, it's not always the case that every column is going to be helpful, because see, what can happen is that the model can try hard to like improve things based on a column, and it can like move in the wrong direction and, you know, not be helpful. Okay, so that'll be our round 1 of, you know, searching, and next we'll move on to round 2.